Hello, my children in Honors Pre-Calculus. Missing you, and I hope you're all doing well. We're looking at starting Unit 11, which is talking about solving trigonometric equations, and it's really an important concept for calculus and for what you're going to need to know beyond this. So we're going to try to take it in baby steps so that it doesn't get too overwhelming. If it does for you, then certainly send me an email and I'll see if I can slow it down even slower than I'm thinking. So here's what we're going to start with. You know the basic trig functions. You know the sine function, right? And you know the cosine function. And you know the tangent function. And what you know about them is that they've got reciprocals. Well, you know, first of all, the sine is the opposite over the hypotenuse. You know the cosine is the adjacent over the hypotenuse. And you know the tangent is the opposite over the adjacent. The other thing that you know is that there's reciprocals involved, that sine goes with cosecant, so that means it would be the hypotenuse over the adjacent. For cosine, it goes with secant, and that would be the hypotenuse. Oh, I just wrote that wrong, didn't I? Oh, where are you guys when you need to help me out here? This is hypotenuse over opposite. This guy's hypotenuse over adjacent. Whew, that's better. Cotangent is the adjacent over the opposite. Now they're called reciprocal functions. So another way that I could think of this, and this is what's going to come into play in the section that we're getting into, is that the sine is equal to the reciprocal, which is 1 over cosecant. They're reciprocals of each other. That's what that's saying. These are called reciprocal functions or reciprocal identities. The cosine is reciprocal with secant. So it'd be like 1 over the secant. You'd be flipping that. And the tangent is reciprocal with cotangent, so it would be like 1 over the cotangent. Now the same thing can be said for this guy, that cosecant is equal to 1 over the sine. This one can be written as secant equals 1 over the cosine. And this one can be written as cotangent is 1 over the tangent. They're reciprocals of each other. This whole set are called the reciprocal trig functions, or trig identities, I'll call them. All right, the next set that's interesting, they're called the quotient identities. You don't necessarily need to know, you just need to know the identity. But the quotient identity, there's only two. And here's what they say. They say that tangent is equal to the sine over the cosine, and that the cotangent equals the cosine over the sine. Those guys are called the quotient identities. And then the last set we're going to talk about today are called the Pythagorean identities. And that's kind of weird, like what's Pythagorean? Pythagoras got to do with all this. But Pythagorean identities. Remember that Pythagorean had all to do with right triangles, and we're still talking right triangles, so it's kind of all the same mode here. But he's got three big guys. He's got three main ones. And the first one says that the sine squared theta plus the cosine squared theta equals 1. That's his first claim to glory. His second one says that 1 plus the tangent of theta equals the these are squares, secant squared theta. That's his second claim to glory. And his last one has to do with cotangents, and it says 1 plus the cotangent squared theta equals the cosecant squared theta. Those are the Pythagorean identities. But the story with them is that you could also take them and rearrange them so that you would have different things solved in the equation. So let me take you and tell you what I'm talking about here. Say I took this and solved it for sine squared. If I looked and wanted to see what is sine squared theta equal to, I'd need to move the cosine squared to the other side of the equal sign. So that would be 1 minus the cosine squared theta. Or say from that same exact identity, the original one, I wanted to know what cosine squared theta equals. Well, that means the sine squared has to come over here with the 1, and it becomes 1 minus the sine squared theta. So there's 3 different forms that I could possibly see this exact same Pythagorean identity written. And I'm going to choose the one that fits for the problem I've got. The same thing can go over here. If I solve for 1 equals, that means tangent comes to the other side. I get secant squared of theta minus a tangent squared theta. Or say I wanted to solve for tangent squared theta, then I'd get secant squared minus 1. Same thing can go for the last trig identity. If I want to solve for 1, cotangent has to go to the other side. I get cosecant squared theta minus cotangent squared theta. And if I want to solve for cotangent squared theta, I would get cosecant squared theta minus 1. So there's different forms that you can see that. All right, here's what we're building towards. We are building towards, as we get to the end of this section, I want to know if you get a problem like this, can you solve it? Say I said to you, find for me the sine squared theta plus the cosine of theta minus 1 equals 0. Tell me the angle, tell me theta where that happens. That's what we're building towards. And we're going to be using all of these identities that you see we just talked about to be able to solve something like that. So there's reciprocal identities, there's quotient identities, and there's Pythagorean identities, and they're all parts of what we're going to be doing in this section that's coming ahead. Building towards being able to solve something like that. So the notes that you have in front of you, or the notes that go with this for day 1, there's 3 days that we're going to do this, of intro stuff before we actually get to the section itself, 11.1. So at the top of your page, you'll see exactly the same things that we just talked about. You'll see the reciprocal identities, you'll see the quotients are kind of mixed in there, and you'll see all the forms of the Pythagorean identities just like we listed out. So everything in the box is exactly the same thing that we just had on our page. And here's how they work. It says use trigonometric identities to write each expression in terms of a single trig identity or a constant. So first example, tangent. Let me tell you a couple things. You usually don't change a sine or cosine. Leave them as sines or cosine. That's one of the big things with these. So if I see this, I've got tangent. And if I look at my list of things that I can call tangent, I have 2 choices to call tangent. I can call tangent, and I'm going to kind of write it over here. I can call tangent, look through my list here. Oh, wow, I could call tangent sine over cosine. Or I can call tangent 1 over cotangent. And so what I want to do is see which one is going to help me to simplify this function. If I change tangent into 1 over cotangent, will anything cancel out? And the answer is no. I'd have 1 over cotangent times cosine. But if I change tangent into sine over cosine, watch and see what happens. Sine theta over cosine of theta, and I'm multiplying that, because this is being multiplied, by the cosine of theta. And you'll see if I do something like that, then I do have things canceling. This is a cosine that's in the numerator. This is a cosine in the denominator. And so when I cancel them out, I get an answer that's just the sine of theta. That's my best answer. That's simplified. That's simpler than what I started out with. And that's what you're looking to do. All right, if I go to part B, 1 minus cosine squared. As soon as you see a square, you want to think about your Pythagorean identities. And I kind of like his writing's okay too. 1 minus cosine squared. Let's see, do we have that anywhere? Oh, look at that. 1 minus cosine squared equals sine squared. So I can replace this. Sine squared theta over cosine squared theta. This turns into sine squared. This stays cosine squared. And I know from my quotient rule that sine over cosine equals tangent. Because these are squares, it just means you're going to have a tangent squared. So this is equal to tangent squared theta, and that is simpler than what I started out with. One more, part C. If I have the cosine times cosecant, remember we don't change sines or cosines, so leave cosine alone. I'm going to keep that as cosine of theta. Cosecant, I only have one choice. I have one choice, and it's 1 over sine. I know you can't see that from what I just showed you, but you have it on your paper. So if I multiply these together, now I have cosine of theta over the sine of theta. This one's over 1. This one's 1 over. So where's my numerator? What's my denominator? So I'm looking through my list. Is there anything I can do better with this? And if I look at the cotangent, cotangent is cosine over sine. So this is cotangent of theta is my best answer. That's what cosine over sine equals. All right, last one like this looks like this. Sine I leave alone, but I'm going to break it apart first before I even do all of my shenanigans. So I have a sine, it's being times a secant, right? They're both up top, times, see how the tangent's in the denominator? I need to say it's in the denominator. I'm breaking it apart. There's 3 pieces. Each piece gets its own little identity. All right, now I'm ready to do my work. Sine stays sine. Sine and cosine you leave alone. Secant, I only have one choice for a secant. It's the reciprocal identity that says it's 1 over cosine. But then I have 1 over tangent. Well, 1 over tangent is equivalent to cotangent. Now, 1 over tangent, realize that that's a fraction, and it equals just a regular old cotangent. So my next best thing, leave a sine alone, leave a cosine alone, change cotangent. Its quotient relationship says that you have the sine of theta times 1 over the cosine of theta. The cotangent is cosine over sine. So if I look at this one and think about what I can cancel, I have a sine on top, cancels with a sine on the bottom. I have a cosine on the bottom and a cosine on the top. Everybody cancel out. I end up with a 1 when they cancel out. Okay, then they're going to get us used to working with some fractions, complex fractions. So I'm not going to do all of these because I think you'll get the idea, but let's pick a couple. Let's do B and D. You know that complex fractions, we've seen these before. You want to go horizontal. They're giving you some practice with numbers before they put it with trig functions. So if I have 4/5 divided by 4 35ths, I don't want to flip it yet, right? Divided by 4 35ths, that means I have 4/5 times keep, change, flip, that's it. So I do 35/4, and then my 4's cancel, my 5 goes into 35 7 times, and I get an answer of 7. This one is like saying 1/2 divided by 2. Well, if I keep, change, flip, I have 1/2 times, if it's a 2, it becomes a 1 over 2, and I get 1/4. And so that's kind of my reminder with complex fractions. And so then they're going to say to you, okay, let's go to example 3, and let's bring in some trig functions into this hot mess. And again, you still have all the identities at the top of your page. So this is like saying cosecant divided by cotangent. Well, cosecant, there's only one thing you can change it to, and that is 1 over the sine. Cotangent, you have 2 choices. You can change it to 1 over tangent. Would that make sense? Would anything cancel? The second choice is to change it into cosine over sine. And if you do to cosine over sine, I think something might cancel. So cosine over sine. And then I want to keep, change, flip. So 1 over the sine of theta times the sine of theta over cosine of theta. Cancel, cancel. I end up with 1 over the cosine of theta, which I can then say 1 over cosine, its reciprocal is secant. For B. Before I do all of that, I want to change 1 minus cosine squared, and you know from up above, 1 minus cosine squared is sine squared. So before I do all my stuff, I know I have sine squared theta, that's the same as the top, divided by the tangent squared theta, if I go horizontal with that. So that means I have sine squared theta times, there's a couple of different ways I can do this, 1 over the tangent squared theta, if I keep change flip. If I have 1 over tangent, that's cotangent. All right, let's take that, sine squared theta times cotangent squared theta. And cotangent, I can either change into, well, 1 over tangent didn't get me anywhere, right? But I can change that into cosine over sine. So here we go. Times cosine squared, because it's squareds, over sine squared. Cancel the sine squareds. Oh, thank God. And I end up with a cosine squared theta. All right. For C, we got 2 to go. For C, I'm going to separate everybody apart from one another. So I have a cosine of theta times a secant of theta times a tangent that's in the denominator. Cosines you don't mess with. Secant can become 1 over cosine. Oh, that's going to make me happy, right? And 1 over tangent is like cotangent. Well, these guys cancel. And I'm left with just a cotangent of theta. I could also change that into cosine over sine. That would be okay. So either cotangent or cosine over sine, whatever you might want to do. And then the last one, this is it. I have the sine of theta divided by the cosecant of theta, or the sine of theta times 1 over cosecant of theta. Cosecant, 1 over cosecant, ends up to be the same thing as sine, so that's kind of interesting, right? I get a sine of theta times another sine of theta, and I finally get an answer that's sine squared theta, and that's my final answer for that one. All right, that's our intro, day 1, into the trig identities. And again, we're going to be building towards trying to solve equations. So for now, your homework problems are numbers 1 through 8 on the homework sheet. And I'll be back to you soon with more examples from day 2. Have a good one. Bye.